In this video, we're going to consider finding an absolute extreme values of a function of two variables on a closed region. So we're given the function f of x, y equals 4x plus 6y minus x squared minus y squared, and we want to find the absolute maxes and absolute min values of this function on the rectangle. X's go from 0 to 4 and y's goes from 0 to 5. So the first thing we do is we find the first partials. The first partial with respect to x is 4 minus 2x. With respect to y, we get 6 minus 2y. And the only time that these are simultaneously equal to 0 is when xy is equal to 2, 3. So that's one set of points that will, one point that we'll need to consider when we're looking for our absolute extrema. We also should make sure that point 2, 3 is in our region D, which it is. The x value is between 0 and 4, and the y value is in between 0 and 5. So now we need to consider the boundaries. We have 4 boundaries to consider. We have x equal to 0, x equal to 4, y equal to 0, and y equal to 5. Well, whenever x is equal to 0 and whenever x is equal to 4, either way, we're going to get the 4x minus x squared will cancel. So the only function we get is 6y minus y squared. Taking the derivative, we get 6 minus 2y, and we get that that's equal to 0 and y is 3. So the other two more points that we'll need to consider are 0, 3, and 4, 3. When we put in 0 and we put in 5 for y, well, we'll get 4x minus x squared, and then either we'll get a 0 or we'll get a 30 minus 25, or we'll get a 5. So we'll get the function of the form 4x minus x squared plus some constant, but that constant's not going to matter when we're looking for critical points, right? It's not going to matter. It's not going to help. It's not going to make any difference in the derivative being 0. We take the derivative, we get 4 minus 2x. That's equal to 0 when x is 2. So 2 more points that we need to consider are 2, 0 and 2, 5. Finally, we also need to consider the corners. There are 4 corners here, so we need to consider all 4 of them. When we plug these points into our original function, we get 4 one time, we get 0 2 times, we get 5 2 times, we get 9 3 times, and 13 once. But what matters is what's the smallest value and what's the biggest value. Well, the smallest value we get out is 0, so that turns out to be our absolute minimum. And the biggest value we get out is 13, so that turns out to be our absolute maximum.